All right, so we have a few properties that we need to talk about. We have something called the addition property, and it says if A is congruent to B modulo n, and you have an integer, well, you can add that integer to both sides of your congruence. Okay, so then I know that A plus X has to be congruent to B plus X modulo n. Also, I know that A times X is congruent to B times X modulo n. So let's look at an example to show this. My first example, like I said before, 3 was congruent to 7 modulo 2. Well, if I were to add a number, let's say 5, 3 plus 5, is it true that that's congruent to 7 plus 5 modulo 2? Well, let's see. 3 plus 5 gives me 8, and then 7 plus 5 gives me 12, and I know that 8 minus 12 is equal to negative 4, and of course this is a multiple of 2. So yes, it is true that 8 and 12 are congruent modulo 2. All we did was we added the same number to both sides of our congruent. 17 we know is congruent to 6 modulo 11, because 17 minus 6 gives me a multiple of 11. Well, let's multiply both sides by 2. So 17 times 2 is congruent to 6 times 2, and we end up with 34 is equal to 12, or congruent to 12 modulo 11. Well, that would mean that 34 minus 12 should be a multiple of 11. What's 34 minus 12? That gives me 22, which is equal to 11 times 2. So yes, assuming that my first two numbers are congruent modulo n, I can multiply the same number on both sides to each of the numbers, and they will be congruent as well. Keep in mind that these examples are not proofs. The proofs are actually in your textbook. I'm not going to take the time to go through every proof. I will pick out certain proofs and I'll go over them. But these examples just help to show that it works. Another property involving congruence modulo n, we have a substitution property. And the substitution property says that if A is congruent to B modulo n, and we know that C is congruent to D modulo n, then that means that I can add A plus C. If I were to add A plus C together, then that would have to be congruent to B plus D modulo n. It also means that if I were to multiply two things that are congruent, like A is congruent to B modulo n, and C is congruent to D modulo n, well, A times C has to be congruent to B times D modulo n. Again, the proof is in the book, but let's go on and just do a couple of examples. So for example, I know that 5 is congruent to 7 modulo 2, and we know that 6 is congruent to 10 modulo 2. Let's double check this. I know that 5 minus 7 gives me a negative 2, which is a multiple of 2. And 6 minus 10 gives me a negative 4, which is a multiple of 2. So we know that 5 and 7 are congruent modulo 2, and 6 and 10 are congruent in modulo 2. So that would mean that 5 plus 6 should be congruent to 7 plus 10 modulo 2. 11 is congruent to 17 modulo 2. And remember, you can look at this in two ways. You could either subtract 11 minus 17 gives me what? A negative 6. And of course that is equal to 2 times negative 3. Or remember, I told you before that if I were to divide my modulus into each number, I should get the same remainder. When I divide 2 into 11, I get a remainder of 1. When I divide 2 into 17, 2 goes into 17 8 times with a remainder of 1. So they both have the same remainders. For the second example, I'm just going to go on and multiply these together. So I know that 5 times 6 should be congruent to 7 times 10 in modulo 2. So 30 is congruent to 70 modulo 2. Well, 30 minus 70 gives me a negative 40. So, of course, negative 40 is a multiple of 2. But also when I divide 2 into 30, I get a remainder of 0. When I divide 2 into 70, I get a remainder 0. So they both have the same remainder.